First law, what's the difference between heat, work, internal energy? Imagine you have a sealed container filled with gas. Now, think about what happens when you heat it up or squeeze it. These actions involve different types of energy transfer. Today, we're going to clarify what heat, work, and internal energy really mean in thermodynamics. The first thing to understand is internal energy. This is the total energy stored inside the gas. It includes the tiny movements of atoms and molecules, like their vibrations and motions, plus the energy from how they interact with each other. Internal energy depends only on the current state of the system, not how it got there. So, if you change the temperature or pressure, the internal energy changes. Next, let's look at heat. Heat is energy moving from one place to another because of a temperature difference. It is not stored inside the system but flows across the boundary. When heat enters the container, it adds energy to the gas, raising its internal energy. When heat leaves, the internal energy drops. Think of heat as energy in transit, always moving from hot to cold, never staying still. Work is a bit different. It is energy transferred when a force causes something to move. In thermodynamics, work often involves the gas pushing against a piston or being compressed. When the gas expands and pushes outward, it does work on the surroundings. Conversely, if external forces compress the gas, work is done on it. Like heat, work is energy in transit, not stored. When work is done on the system, the internal energy increases. When the system does work, the internal energy decreases. The first law of thermodynamics ties all this together. It says that the change in internal energy equals the heat added plus the work done on the system. Mathematically, it's written as the change in internal energy equals heat plus work. If heat flows in or work is done on the system, the internal energy goes up. If heat leaves or the system does work, the internal energy drops. This law keeps the total energy of the system and surroundings constant, showing energy cannot be created or destroyed, only transferred or transformed. So, when you heat a gas, you increase its internal energy, which can cause it to expand and do work. When you compress a gas, you do work on it, increasing its internal energy and temperature. Understanding these differences helps explain many everyday phenomena, like why heating a container makes the gas inside expand or why squeezing a bicycle pump heats the air. In summary, internal energy is the energy stored inside the system. Heat is energy transferred due to temperature differences. Work is energy transferred through force and movement. All three are connected through the first law, which governs how energy flows and changes form in thermodynamic processes.